After the worldwide flood, the Earth entered a worldwide ice age for around 400 years. High snowfall rates could easily form the thick ice sheets we see today. Ice sheets don't need hundreds of thousands of years to form. They were part of the ice age that was caused by the flood in Genesis, the first book of the Bible.
Today's lesson is lesson 2, entitled Post-Flood Weather and Climate. It's part of series 3 after the Genesis flood. Last week, if you recall, we discussed the Ice Age, only the Bible explains it. And next week will be the third lesson of this short series, the Tower of Babel and its impact and the origin of nations. As I mentioned last week, I'd like to acknowledge Michael Ord, who invented the Ice Age model. And I'll be referencing this book again for this session, this lesson, An Ice Age Caused by the Genesis Flood. Also his book called The Frozen Record, Examining the Ice Core History. And I'll be introducing 2 more books. Michael Ord wrote this one, Frozen in Time, The Woolly Mammoth, The Ice Age in the Bible, because we'll be discussing what happened with the woolly mammoths. And this one's from Professor Dr. Jake Hebert from Institute for Creation Research, and he has a book entitled The Ice Age and Climate Change, A Creation Perspective. It's a pretty thick book, and I have it up here if you're interested in looking at it afterwards. So let's start with today's outline. It's a long outline because there's like a lot of small topics I want to cover. So first I want to review last week where we talked about the Ice Age model mechanism. And we use the acronym HEAT. So try to think of what those letters stood for. And then point number 2, post-flood weather modeling impact. And I have another book up here from Larry Vardaman, Climates Before and After the Genesis Flood. And we'll pull out some of his research that he found using National Weather Service models. Point number 3, Ice Age model support. We'll talk about the wet deserts. The Sahara used to be luscious and green. Why did the lowlands of Siberia, Alaska, and Yukon remain unglaciated? The secular models can't keep it unglaciated. We'll talk about the woolly mammoths. What happened to them? Did they actually exist? Where did they go? And then mass extinctions at the end of the Ice Age. Point number 4, address challenges of the ice cores. Secular scientists like to bring up ice cores and say that, there's evidence here of the Earth's hundreds of thousands of years old, and we'll address those challenges. And 5, we'll look at the book of Job and how Job ties into the Ice Age, because there's more ice and snow references in that book than any other book of the Bible. So time frame for the Ice Age. I brought this up last week. Session 1 was before the Genesis flood. And we talked about the pre-flood climate and how people lived longer and what the earth was like. And then session 2, we discussed the flood and how there you have God made climate change, or God created climate change, where it ripped up this world and buried it with thousands of feet of sediment. And then now we're in the transitional climate. That's where the Ice Age occurred. After God caused the global flood and changed the world forever, the world's now transitioning, recovering from all that damage. So that's where the Ice Age fits in. And then, of course, we're in the present climate where everything has finally tapered off. So let's revisit the Ice Age mechanism. We need heat. Anybody in the audience remember what H stands for? Any guesses? No. Yeah, very good. Yep, hot water. So, and that's what happened when the fountains of the deep and all the volcanism, it warmed up all the oceans. Remember I said you could Noah could have took a swim in the Arctic Ocean. What was E? Huh? Evaporation. So when you have the hot oceans, you get all that moisture to come on land and provide rainfall, snow. and we'll get into that today. And what about A? I remember what A is? All right, aerosols. Remember we said all the volcanism, and it went up into the stratosphere and trapped and blocked the solar radiation, which cooled down the land. And anybody remember what T stands for? Time. Very good, time. And we said short time scales, which matches the Bible. So I have a short clip from Institute for Creation Research. It's called That's a Fact, and they have one on the Ice Age that I'll play. Summarizes last week's lesson.
Ice sheets, saber-toothed tigers, and woolly mammoths. The Ice Age sounds like a cool time. But what caused it? Ironically, you need warmer sea surface temperatures to get an ice age started. Extra heat would make more water vapor that would cool high in the sky and then fall as rain or snow. Lots of snow. But were the oceans once warmer? The Bible tells us that during the Genesis flood, the fountains of the deep were broken up. This coincides with geologic evidence of past volcanic activity. Dramatic eruptions released untold quantities of magma and steam into the waters that once covered the globe. Since water holds heat, even after it receded off the continents, those warmer oceans would have led to more snowfall. And that's how we can explain the way the Ice Age began. But for it to continue, the snow would have needed to stay frozen all summer long. The flood explains this too. Aerosols, tiny particles released from flood-associated volcanoes, would have reflected sunlight away from Earth, preventing the snow from melting. Once the aerosols dissipated, enough sunlight would have eventually broke through to warm summers and melt ice. In just hundreds of years, the peak of the Ice Age was here and gone. This cool time period that we call the Ice Age clearly requires hot oceans and volcanic debris, definitely caused by catastrophic events. Secular scientists believe that slow and normal processes, not a global flood, caused many ice ages over eons. But without a worldwide catastrophe, they can't explain the heat and aerosols needed for even one ice age. We can fully trust God's Word, which gives us the clues to explain the recent Ice Age.
Okay, so point number 2, post-flood weather modeling impact. And I mentioned I have Larry Vardaman's book up here on climates before and after the Genesis flood. So let's talk about some modeling that he did. 2 points. 1, post-flood modeling of precipitation and glacier development at Yosemite Park. Did you know Yosemite Park had thousands of feet of glaciers in the past? Also, we'll talk about post-flood, not hurricanes, but hypercanes. Point number 1, Yosemite National Park. Larry Vardaman and Dr. Brewer did a numerical simulation of precipitation in Yosemite National Park using the warmer ocean. And this is what they discovered. So they ran the model similar to what we use at the National Weather Service, and they just tweaked the sea surface temperature. They started with a sea surface temperature or water temperature of 10 Celsius. And the storm produced some precip, and that circle is close to where Yosemite Park is. They increased the temperature to 20 Celsius, and it produced a little more rain. They bumped it up to 30, and it started producing a lot more rain. Once they hit 40, the rain values kept going up. And notice here on the eastern side of the mountain in the desert, we start seeing significant precip as well. So with a sea surface temperature of 45 degrees Celsius, we get tons of rain, both all across the state of California and also east of the mountains. So here's the schematic where we look at accumulated precip in millimeters versus time. And every time the sea surface temperature goes up, the model produces more rain. That makes sense. Also, they looked at precipitation rate with glacier development. So they found out that if you had, say, a mean, you increase the sea surface temperatures, you get about, on the mean, 40 short waves per year or 40 storms across California. And then that produces enough glaciers for Yosemite Park of about anywhere from 2,800 to 3,800 feet per century. So that's plenty of ice for Yellowstone Park to build up their ice in 100 or more years. Now, I did want to highlight about the warmer oceans significantly increase the precip in the desert area. We know it'll do it over the land of California, but let's focus in on the desert. So, when the deep upper low had a sea surface temperature of 10 degrees Celsius, it would produce 5 millimeters of rainfall. What's 5 millimeters? 2/10 of an inch. That's, hardly anything. And that's almost like your average storm today in the desert. Now, if you heat it up to 20 Celsius, that gives you 10 millimeters or 4/10 of an inch, so it doubles. Let's go, once you heat it up to, say, 40 degrees Celsius, it gives the desert 100 millimeters, and 45 gives it 200 millimeters. What's 200 millimeters? That's almost 8 inches of rain. So the desert precip increases from 5 millimeters, like for today's sea surface temperatures, to 40 times that, to 8 inches per storm. So you could see by just increasing the Pacific Ocean to, say, 40 or 45 degrees Celsius, that can give plenty of rain into the desert. I have a clip here from Institute for Creation Research where they talk about the computer modeling providing post-flood ice age model.
The destruction of Noah's flood being catastrophic enough to cause a worldwide change in climate, enough to cause one ice age? Creation scientists think it's entirely plausible, and they are using sophisticated computer modeling to prove it.
When the heat came up from the plates in the oceans, it caused the oceans to become very warm, and it would be like a giant El Nino effect. Well, can you imagine if the oceans were 20, 30, 40 degrees warmer than they are today? We would expect all kinds of severe weather, gigantic hurricanes, which I call hypercanes, and this would produce all kinds of evaporation into the atmosphere, which could then come out as snow in the polar regions and on mountaintops. I've modeled that with conventional models with a sea surface temperature hotter than we would normally experience today. When that happens, these models predict much, much greater precipitation rates, particularly in the polar regions and on mountaintops. And we can explain the ice age in less than 500 years simply by the warmth of the ocean.
He also did a simulation in his book on Hurricane Florence. That was a hurricane in 1988 where it started out as a tropical depression, tropical storm, intensified just to a hurricane, a Category 1 hurricane, and it hit shore near New Orleans and then dissipated. So this is what it looks like on the infrared, and you can see this infrared satellite picture taken on September 10th, 1988 at 0031 UTC. That would be 7:31 p.m. Eastern Time. And when you look at this as a meteorologist, you really don't see much of an eye in the infrared. So this is kind of a ragged, weakish-looking hurricane. And then if you look at the actual visible satellite, you can kind of make out maybe a little center of circulation. But, this is a wimpy storm. Now, he ran this storm using the MM5 model, and he warmed the sea surface temperatures, say, all the way up to 45 degrees Celsius. You convert that to Fahrenheit, it's 113 degrees. Because the Gulf of Mexico, if you've ever been down there, it's warm. It's like a bathtub. In the summertime or early fall, it's in the mid-80s already. So say you warm that up to 45 degrees, 113, it quadruples the horizontal wind speeds. So if you have a hurricane of, say, 80 miles an hour, which be closer to a Category 1 hurricane, that means the max winds would be up to 320 miles an hour. It also would double the vertical wind speed. So if you have strong updrafts in the middle of that hurricane, it'll sustain a lot of heavier precip. And the model increased the precip 10 times what a normal hurricane would by just warming up the sea surface temperature. And many hypercanes were likely after the flood. And of course, the side effect would be incredible erosion, especially near the shore after the flood. So here's a simulation that he used in his model, which came with the book. And what I wanted to show here on the right is those are the Rocky Mountains, and then on on the left, the Rocky Mountains, on the right is the East Coast. And within hours, the yellow are the clouds and the green is the rain. So within hours, we had a massive hurricane, and the cloud shield would go all the way to the west coast, off the coast of California, and off the east coast. And you can see these rain shafts that are very intense. So that's the post-flood weather modeling impact. Hypercanes, we have wet deserts, and I'll get into that more. So point 3 is the Ice Age model support. Wet deserts. The Great Basin, right after the flood, there were a lot of big, massive, huge lakes, because when God lowered the ocean, all the floodwaters came off the land and raised the mountains. Most of those floodwaters are now in the ocean today. But a lot of the Great Basin area had leftover water. In fact, there's a Lake Bonneville in Utah. This is the lake here. And at its peak, it was 800 feet deep. You know, we used to live in Salt Lake City for over 3.5 years, and we lived on the West Jordan, which was like a bench area. Of course, at the peak, it would have been even over the bench, but the bench area was like the seashore of that Lake Bonneville. Most of the people lived down in the bottom of the Salt metro area. But at the peak, it was 800 feet deep. Now the Great Salt Lake is just a very small representation of those Ice Age lakes. It's only 15 feet today, and it's still falling and evaporating. But we also had lakes all across Nevada as well, and most of these lakes are gone. You still have Lake Tahoe. So what I wanted here's a video talking about not necessarily the western U.S., but the Sahara Desert. And they talk about how there was an abrupt change from dry to green in the past. And then I'll dive in more after this short video.
The Sahara Desert in Africa is the largest hot desert on the surface of planet Earth, but it used to be populated by rich plant life and several lakes during the era known as the African Humid Period from around 5,000 years ago. Research from the Massachusetts Institute of Technology, along with other studies, show that the area dried up in only 100 or 200 years. Prehistoric cave paintings in the area show herds of elephants, giraffes, and hippos in watering holes.
So here is what Africa may have looked like shortly after the flood. And there's evidence of two great lakes, with very lush and very green. Here's a picture of Africa today. It's the world's largest desert across the northern third of the continent. And some places may not see measurable precip for years. So what a dramatic change in northern Africa. Here's what northern Africa could have looked like after the flood, with trees and lakes and ponds. You would need that to have animals like elephants and giraffes and that we're seeing evidence to survive. But this is what northern Africa looks like today. You see evidence of old rotting trees buried in the sand. In the Sahara Desert today, there are petroglyphs. And here's a petroglyph of a giraffe. And you'd think, why would a giraffe be in a desert? Here's James Wellard from the Great Sahara wrote this. The Sahara is a veritable art gallery of prehistoric paintings. The evidence is enough to show that the Sahara is one of the well-populated areas of the prehistoric world. Yet there is man's work in the most inaccessible corners of the desert. Literally thousands of figures of tropical and aquatic animals, enormous herds of cattle, hunters armed with bows and boomerang, and even domestic scenes of women and children and the circular huts in which they lived. You would see the climate today, and there's no way that could exist in that type of climate. I found a little clip I'd like to show you. Instead of explaining this further, this actually shows some of the petroglyphs and some of the paintings describing what that gentleman just brought up on what it used to look like. So there's some rock paintings of people and cattle. Another sculpture, cattle. There's a hippopotamus. Looks like some type of reptile, alligator lived there at one time. They're making paintings of scratches on the rock. There's a rhinoceros. This will transition into people. It's like people with pottery balancing on their head. There you see some giraffes and elephants. Another giraffe there. And this is all in the Sahara, where it's a desert now. People dancing. So you get the sense. So the deserts, like I showed you in the west and also in the Sahara, used to be lush and wet. But the climate changed since then. Another support for the Ice Age model is the lowlands of Siberia, Alaska, and the Yukon remained unglaciated. I showed this last week, where the lowlands of both Alaska and Yukon did not get glaciated during the Ice Age. And we find woolly mammoths, woolly rhinos, bison, and horses by the millions, hundreds of thousands living there. And then the climate changed, and I'll get into that. Also, when we look over in Asia, up here in the far right is northern Siberia, and it didn't get glaciated as well. Remember I said about this study from Newsom in 1973? He looked at the response of general circulation model of the atmosphere. If we remove the Arctic ice cap, and if we just remove the Arctic ice cap, the North Pole could warm up as much as 30 to 40 degrees Celsius, because that ice cap reflects the incoming solar radiation and keeps it cold. If there's no ice, and there was no ice at the Arctic, after the flood. Remember, I said you could take a bath. Noah could take a swim in the Arctic Ocean because it was so warm. It would have been even warmer up at the North Pole. So here is another picture showing the glaciated and unglaciated areas. So notice parts of Alaska remained unglaciated. Also in Russia, up in Siberia, remained unglaciated. Why would that happen? Well, if you think about it, the Arctic Ocean would have been warm, and you would get warm air off the Arctic Ocean coming into the land, keeping Siberia, keeping Alaska, keeping the Yukon warm during the coldest time periods. And you would get storms coming in from the west, and it would snow on the highlands, but keep the lowlands less snow, and it would make the grasslands grow crazy and a lot of vegetation for animals. Here's a quote from Phillips and Held from the Journal of Climate. Siberia, Alaska, and the Yukon, including the lowlands, were among the first to glaciate in the model. We now have glaciation, but mainly outside the area where it existed during the last ice age. What he's getting at is when secularists run their model, they get glaciation at the lowlands, not at the highlands. But that's not what happened. the glaciation did not happen in those areas because you had the warm waters keeping it warm. The third support for the Ice Age model, we'll get into woolly mammoths that lived in Siberia, Alaska, and Yukon. There's a picture of a woolly mammoth. By a show of hands, has anybody ever heard of a woolly mammoth before? Okay, looks like most people have. Good. Now, the woolly mammoths are mysteries. There's many mysteries associated with them. We'll get into that. Evidence points to an extinction of all the woolly mammoths at the end of the Ice Age. And the post-flood Ice Age, deduced from the Bible, can account for these mysteries. The woolly mammoth, as you can see on the picture there, is a hairy elephant. It has a hump on its head and shoulder, and it has hair 18 inches long. And you can see in the front they have long, curving, inward spiraling tusks. And they lived in the northern latitudes, especially in Siberia, Alaska, and the Yukon. And here's a picture of where the woolly mammoth distribution was, and you can see it's mainly in the north latitudes. Specifically, they lived in Siberia and this island just north of Siberia, and I have a short clip I'll show you about that. So this is what John Massey Stewart wrote in the Smithsonian. He said almost 50,000 mammoths are said to have been found in Siberia between 1660 and 1915, serving an extensive mammoth ivory trade. Along the 600-mile coastal shallows between the Yana and the Kolyma lie more than 500,000 tons of mammoth tusks and another 150,000 tons in the bottom of the lakes of the coastal plains. So let's look at this. If the tusks weigh 100 pounds, you have 2 tusks, so you could say there were at least 6 million woolly mammoths in that area. That's a lot of woolly mammoths. So there's 3 mysteries. Why would they live in Siberia? You know, you think of Siberia, that's a place where the Russians send people to be punished. You know, that's one of the most coldest places on earth today, where the winters are bitterly cold. Also, they have boggy land in the summer. Boggy land, it's frozen land, and then in the summer it melts and it gets like 2 feet deep, and it's kind of mushy and muddy. And what would the mammals eat? These woolly mammoths were grazers, and there's no green vegetation up in Siberia today until July. And most bog vegetation is toxic to elephants. They can't eat that today. And most of those woolly mammoths or elephants today require like 440 pounds of fresh vegetation and 50 gallons of water a day. Can you go up there and they can eat that? No. So, third mystery, how did they die? Why would they live there? What would they eat, and how did they die? So let's look at the Siberian mammoth steppe environment. They need a grassland with wide diversity of plants. They need fertile soil, unlike today. They need high-quality habitat with light competition. And the vegetation requires long growing season with warm soil and rapid spring growth. They would need light snowfall, and the snowfall would have to melt early to get the greenery growing quick. And they would need mild and relatively dry winters, and summer bogs rare. And they need little or no permafrost. What do we see today in the permafrost? Well, the North Pole is frozen tundra. It's frozen over with ice. Greenland's a continent full of ice. But you can see in northern Canada and in Russia, it's permafrost where there's no ice. They'll get ice in the wintertime, then it retreats. But it's full of permafrost. And this is what Tolmachoff, Transition of the American Philosophical Society, said. We must explain the extinction of an animal which was living in great numbers, apparently very prosperously, over a large area and variable physico-geographical conditions to which it was well adapted and which died out in a very short time, geologically speaking. This great extinction, this is Peter Ward, The Call of the Distant Mammoths. This great extinction represents one of paleontology's most fundamental mysteries. So you can see they have no answers. Anyone ever hear of the Berezovsky mammoth? Anyone hear of that one? Well, this mammoth is in the Zoological Museum in St. Petersburg, Russia. And it's one of the most well-preserved mammoth specimens in the world. This mammoth was discovered in 1900 near the Berezovsky River in Russia. The body was excavated in 1901 and brought to St. Petersburg. It had been inside the permafrost and was incredibly well preserved. The body only had a few marks, and part of the trunk, I don't know if you see this trunk here, was torn off. And also most of his hair was ripped off. You can see over there the back, there's no hair left. But we can see some of its fur on the upper regions of its front legs. And its body is prominently displayed in a glass cabinet. So Henry Howarth, The Mammoth and the Flood, writes, "Now, by no physical process known to us can we understand how soft flesh could thus be buried and ground while it's frozen, as hard as flint without disintegrating it. We cannot push an elephant's body into a mass of solid ice or hard frozen gravel and clay without entirely destroying the fine articulations and pounding the whole mass into a jelly, nor do we fail in greatly disturbing the ground in the process." So they have no answers on how that mammoth was preserved the way it was. Also, you need to know about a mammoth's digestive system. It's based on post-gastric or hindgut fermentation. Whoops. The stomach is large, but serves mainly to store ingested food. Enzymes within the stomach partly break down the vegetation, but most nutrients are extracted in a huge cecum and large intestine, where microbes ferment the food remaining after gastric processing. So what they're finding in these woolly mammoths is they have the hindgut. They'll eat food, but it gets processed later, and sometimes they'll find the vegetation they ate inside their intestines, and also they eat buttercups, and they'll also find it in their stool. We said 2 elephants, the elephant kind, so it'd be 2 elephants coming off Noah's Ark. So from the time, that was about just under 4,400 years ago, so you had 2 elephants coming off the Ark. Those elephants have babies, and then the baby's elephant have babies. So let's look at population. How could you have millions of woolly mammoths in such a short time frame? Well, if you look at, say, the elephants doubling their population in 25 years, remember we said the peak of the Ice Age happened in roughly 500 years. If you double the elephants' population every 25 years, you could have 8 million elephants in 550 years. If you double the elephant population in 18 years, you could have 657 million elephants in 500 years. And if you double the elephant population every 10 years, you could have 1.3 billion elephants in 300 years. This is evidence showing that the population growth becomes exponential. So here is a flood to present woolly mammoth timeline. So on the left axis, we have the number of woolly mammoths, and then we go from the end of the flood on the x-axis all the way to 700 years, and then eventually to the present. So what we see was there were 2 elephants that left the ark, and they started populating. It goes to an exponential curve. Remember, where a lot of them went up into the Siberia, where it was a luscious greenery. The warm Arctic Ocean kept it warm for them. And they had grassland and water everywhere. It was the perfect environment, and it caused their population to, increase exponentially. But when the colder, drier, windier climate shifted, then they dropped off and went extinct rapidly. Here's the postulated Siberian temperature with time. So we have temperature on the left axis here, and on the x-axis you have time, so the end of the flood all the way to today. So it was warm, both summer, yearly average, and winter, and then with time, the Arctic Ocean started cooling down, and then finally it would cool down to the point where the Ice Age hit its max, and it started changing the climate where the woolly mammoths were and killed them off, and it stayed cold. Also, here's the postulated annual precip with time. At the end of the flood, up there, it was the peak of the rain because you had the Arctic Ocean so warm, and it would start slowly dropping precip with time until it hit the peak of the Ice Age. And then today, the precip started increasing a little bit, but not as much as it was at the end of the flood. Permafrost, postulated area of Siberia, permafrost with time. At the end of the flood, no permafrost. But when it started cooling down, the permafrost started developing. And then it peaked at the end of the Ice Age. And it dropped a little bit, but so that's what helped kill off the woolly mammoths. And here's James Wellard, the great Sahara, said, the solution to the mystery of their extinction is found in the deposits surrounding the mammoths. Like most of the Soviet Far East, large expanses of the Alaska and Yukon Territory were not glaciated during the Pleistocene or Ice Age time frame. Because these areas were bounded by enormous glaciers and glacial outwash streams today, this area is mantled with a thick deposit of Elion, wind-blown silt called loess. And that's just a fancy word for dust. So these, like that woolly mammoth you saw in St. Petersburg, he was buried in dust. What analog do we have? Hopefully a lot of you heard about the Great Dust Bowl that happened in the Central Plains in 1936, where we had massive dust storms. And the dust would pile on top of roofs where it would be, 20, 30 feet high. So we have an analog to that. But the thinking was that these woolly mammoths were covered in 100 feet of this loess or dust. So the thinking was they were buried in a dust storm. So why late Ice Age dust storms? Well, the winters became colder. The ocean started to cool down. Then you develop more sea ice. The atmosphere started to dry out. And then that developed stronger north-south temperature differences, which increased the wind. So here's our woolly mammoth. It's in St. Petersburg, Russia. And he's sitting out there, and we have a big windstorm coming. I'm going to play this short video here, animation. So the wind's coming. He has nowhere to go. So he will start backing into the wind. And the dust starts to accumulate on top of him. And he slowly gets buried alive with the dust, just like those buildings did in the 1930s, until he was suffocated. And then he was buried in the dust, and then it would turn hard with some of it freezing over. And there's analogs of animals in the U.S. where when they were buried in mud or dust, that they would try to escape and they would break their legs. And that's probably what happened to him. And so he was buried in this frozen dust, and then eventually he would break his back, and then you could see him in that sitting position like this. So the post-flood rapid ice age accounts for the lowlands of Siberia not glaciated, so allowing all these animals to live there and thrive for hundreds of years. And this accounts for why mammoths lived in Siberia. It was great eating for a while. Also a mix of warm and cold climate animals. I didn't get into the warm climate animals. It wasn't just woolly mammoths and, it was also different type of animals like bison and deer and other animals that were killed as well up there. Before the Ice Age peak, there's abundance of food. And also the post-flood rapid Ice Age explains accounts for how mammoths and other animals went extinct. So the fourth support for the Ice Age, mass extinctions at the end of the Ice Age. So during the Ice Age, you had saber-toothed cats. You probably heard of those. Woolly mammoths. There was also woolly rhinoceroses as well. So the mass extinctions. There were 100 species of large animals in North America who died. 70% of them died in North America. We're talking Alaska and the Yukon. There's also species of horses and camels who died. Europe and Asia, 75% of the animals died at the end of the Ice Age. Australia was even worse. 90% of the animals died due to the dust storm's colder and drier environment. Alroy in the Extinctions and Near-Time Causes, Contexts, and Consequences in 1999 writes, after many decades of debate, the North America and Pleistocene megafaunal mass extinction remains a lightning rod of controversy. The extraordinary divergent opinions expressed in this volume show that no resolution is in sight. And then P. Ward in The Call of Distant Mammoths, Why the Ice Age Mammoths Disappeared, wrote, this great extinction, truly a mass extinction, represents one of the paleontology's most fundamental mysteries. They have no answers because their model doesn't account for this. Christians, you use the global flood, the warm oceans, where we had warming up there for a while, and then the climate changed dramatically and killed all those animals. So the Bible explains what happened with the woolly mammoths and how they died. Secular scientists have no answers. The fourth point, we talked about Ice Age model support. Now I want to go to address challenges of the ice cores. And we do have challenges of ice cores. Greenland ice core is claimed to detect annual layers to 110,000 years. And they hold to that. They say the Earth is older than 6,000 years as the Bible teaches. It's because we found 110,000 layers in the Greenland ice cores. Antarctica Dome Sea ice core claims to have reached 900,000 years. So the claim from the secular scientists are, we have hundreds of thousands of yearly layers in the ice core, so there's no way the world can be 6,000 years old. In fact, Bill Nye brought this up in his debate with Ken Ham on ice cores, and I want to play this clip so you can see what he says.
My scientific colleagues go to places like Greenland, the Arctic, they go to Antarctica, and they drill into the ice with hollow drill bits. It's not that extraordinary. Many of you have probably done it yourselves, drilling other things, hole saws to put locks in doors, for example. And we pull out long cylinders of ice, long ice rods. And these are made of snow. And by long tradition, it's called snow ice. And snow ice forms over the winter as snowflakes fall and are crushed down by subsequent layers. They're crushed together and trapping the little bubbles. And the little bubbles must needs be ancient atmosphere. There's nobody running around with a hypodermic needle squirting ancient atmosphere into the bubbles. And we find certain of these cylinders to have 680,000 layers. 680,000 snow, winter, summer cycles. How could it be that just 4,000 years ago, all of this ice formed? Let's just run some numbers.
It's more than 4,000.
This is some scenes from lovely Antarctic. Let's say we have 680,000 layers of snow ice and 4,000 years since the Great Flood. That would mean we'd need 170 winter, summer cycles every year for the last 4,000 years. I mean, wouldn't someone have noticed that? Wow. Wouldn't someone have noticed that there's been winter, summer 170 times one year?
Explain what happens here in Greenland. They do ice core drillings in Greenland, mainly in the GISP 2. There's a giant freezer to store the ice cores in Denver, Colorado. And also textbooks, University of Wisconsin-Madison, talk about this. But in order to account for annual layers, you have to first correctly identify them. there's distinct layering at the top of the cores, but the layers start to blur and thin with increasing depth. So to try to date the core, you have to know how much thinning has occurred. And here's a short video showing a vertical compression of an annual layer due to pressure from the ice above, which is compensated by horizontal stretching. So, uniformitarian assumptions of ice sheets. The Greenland and Antarctic ice sheets existed, they believe, millions of years ago. So today's ice sheets remain steady over this time frame. That's what they believe. Ice and snow added each year is balanced by lost ice through melting and icebergs breaking off into the ocean. But they believe the bottom of the ice sheet is at least 250,000 years or older. Older ice may exist, but is presumed too small to resolve paper-thin annual layers. Compressed thin ice presumably mixed with ice of other ages. They do not believe in subannual ice core cycles or compression. What do I mean? They disregard multiple cold, warm weather patterns in the winter. Some of these core patterns could be you had a snowstorm, it warmed up, melted, and then you had another snowstorm on top of it, warmed up, melted. They interpret every little line to be yearly cycles, and they disregard large snowstorms each winter. So if you look at the time since the flood and the buildup of the Greenland and Antarctic ice sheets, the volume, there was nothing at the flood, and then it built up dramatically during the Ice Age with all that moisture coming on land and building up the snow. And then, after the Ice Age, it leveled off, and present, it's not building up anymore. Also, the difference in the creationist model and the uniformitarian model. They disregard the whole Noah's flood and the surge we had in the Ice Age in a short time frame. The creationists believe that during the peak, we could have built up almost 10 feet of ice per year. The secularists believe at the same time frame only 1.2 inches of ice per year. So at 1,600 meters or 5,200 feet down the ice core, the creation model is 100 times more than the uniformitarian estimate. Here's a guy, it's the promise of sleep, but he tells you where you can have a mindset of uniformitarian and not take in any other belief system. Here's what he says. Even when they're looking, people usually see what they expect to find, and they do not see what they assume for whatever reason could not exist. In other words, when your climate worldview only sees old age, that is only what you see. And what they do is they'll look at these little wiggles, 8 millimeter resolution, and they say, oh, those little wiggles come up to, they have to be yearly, so there's 85,000 years. But it doesn't agree with a deep sea course, so they say count again. So they come back and they look at, oh, let's find even more little wiggles. So the second count, they look at 1 meter resolution, and then they come up with 110,000 years. So they had to add 25,000 years to match the desired amount. So they fit the counting to match their belief system. Now, to combat all this, I want to show you the example of the Lost Squadron. Pat Epps, in 1942, there was a squadron of 6 P-38 airplanes and 2 B-17s going to England during World War II. The fog closed the airports in England. They had to turn around, and the fog closed the East Coast airports too. So they circled and landed in Greenland and were rescued. Pat Epps went to look for these planes 50 years later. Here's where the planes flew in Greenland in 1942. So they left northern Canada here, and they went over Greenland. They were planning to go to London, but with the fog, they turned around and crash land on southeast Greenland. So Pat Epps and his team, 50 years later, did advanced radar detection, tried to look for the planes, 260 feet of but they found them 260 feet of ice below the surface. So the lost squadron was covered by 260 feet of ice in 48 years. How they dug it out, they built special equipment to dig out the planes called a conical gopher, where they had copper tubing and warm water, and they kind of drilled holes down 260 feet. And here's a picture of where they dug out 4 pits, and the people dug out intermediate snow and ice in between down to 260 feet. And here's a diorama you have at the Ark Encounter with the lost squadron. And you can see the top and where they had to dig down 260 feet. Here's a zoom in of the top of it, and then here's a zoom in of the bottom. And they found the planes. And what they did was they dismantled the P-38. And there's a picture of it actually when they dug it out and what it looked like. So the P-38 was called Glacier Girl and only had minor damage. They pulled out the pieces and took it to Houston, and they repaired Glacier Girl, and it flew again in 2002. And then when they were drilling down, they said that there are many hundreds of layers of ice above the planes when they dug them out. So let's do some math. 1942, when they crash land, they found them in 1990. That's like 48 years. The planes were 260 feet below the surface. So that's about 5.4 feet of ice buildup per year. So if you look at 10,000 feet of ice divided by 5.4 feet per year, that gives you 1,852 years of ice buildup. So the deeper ice is pressed into finer layers. So 4,400 years since the flood it can accumulate the ice at the pole is no problem. For example, here's someone that was in, I guess, Alaska and said, I got 15 layers of snow in my car in 8 hours. And they showed the examples of the snow layers.
Secular scientists often say that thick ice sheets like those in Greenland took hundreds of thousands of years to form. They say each layer represents 1 year, so all you do is count the layers to get the age, right? Wrong. It's not that simple. Scientists pull out long tubes called ice cores. At the top, the layers are easy to make out, but does each layer really represent 1 year? Crater Glacier on Mount St. Helens is only 30 years old, but it's already over 300 feet thick. This is because winter storms can deposit multiple layers at a time. So when counting ice cores, scientists have to guess at how many layers count as 1 year. Deeper down, the layers get squished together. It becomes impossible to see them. Scientists have to find a different way to count. One way is to measure the amount of dust in each section. They assume that a spike in dust content represents 1 year. But dust storms and snowstorms can cause multiple spikes in each section. Other times, scientists use mathematical models to estimate how many layers are in a section of ice. But these models assume hundreds of thousands of years to begin with. No wonder they think ice sheets are old. Creation scientists have a different answer. After the worldwide flood, the Earth entered a worldwide ice age for around 400 years. High snowfall rates could easily form the thick ice sheets we see today. Ice sheets don't need hundreds of thousands of years to form. They were part of the ice age that was caused by the flood in Genesis, the first book of the Bible.
And then we'll end with this, the book of Job and the ice age. Now, in the book of Job, I wanted to highlight that Job lived about the time of Abraham. Climate was cooler back then. There's more references to snow, ice, and cold than any other book of the Bible. In fact, may be referring to the snow and ice at higher latitudes near the Middle East when Job was referencing it. And I'll just go over some verses that's in Job. Job 42, verse 12. Now the Lord blessed the latter days of Job more than his beginning. After this, Job lived 140 years and saw his children and grandchildren for 4 generations. So Job died old and full of days. So note, Job lived long enough to have one family of 10 children, raise them to adulthood, then have a second family and lived another 140 years. So he probably lived maybe 200 years or longer. And this is consistent with the age of the patriarchs just during or just before the time of Abraham. Abraham lived 175 years. Terah lived 205 years. Isaac lived 180 years. So the speculation is we think Job lived close to the time of Abraham. But another thing I found out looking at this, did you know Shem lived 600 years? When he died, he could have been old enough for Jacob when he was born to see him. It's pretty amazing. So the Ice Age peak was about 2,158 years after the beginning of the world. So here's the verses I want to show you where it talks about snow, ice. Job 6:15, my brothers have dealt deceitfully like a brook, like the streams of the brooks that pass away, which are dark because of the ice, and into which the snow vanishes. Job 24:7, they spend the night naked, without clothing, and have no covering in the cold. 19, as drought and heat consume the snow waters, so the grave consumes those who have sinned. Snow waters is the same as melting snow. Job 37:6, for he says to the snow, fall on the earth, likewise to the gentle rain and the heavy rain of his strength. Job 37:9 and 10, from the chamber of the south comes the whirlwind, and cold from the scattering winds of the north. By the breath of God ice is given, and the broad waters are frozen. And Job 38:22 and 29 through 30, have you entered the treasury of the snow, or have you seen the treasury of hail, from whose womb came the ice, and the frost of heaven, who gives it birth? The waters harden like stone, and the surface of the deep is frozen. Thank you for your attention.